Hello friends, let us see another concept called backtracking. I think the name itself tells what it is. Back means going behind. Tracking means I trace, right? So let us take a simple. I know it's an error of GPS, but still we sometimes will consider this example which may be. So when we are searching for a road, okay, so what happens? We try to go and reach, when we are searching, so we go to a dead end of it, a road, right, which is maybe not a destination. So what we do is, we just turn back and see where we reached. Then we see, is it possible to go from here? If not, again we go behind. So you understand, in this case, so I go for a particular, from a point towards a solution. When I know that it is a dead end, then I try to come back. Where can I get this, right? So in a simple this, say nowadays we are more with the technology and this. See, I am adding something or I am doing any calculations. When I know that I went wrong with my total or something, so what we do? We backtrack where we have made, okay, a mistake. So when we are solving a big line of derivation, so say I may not get in what I expected at the end, so I don't go and start solving it from back. So I just start doing it one step here, here and here. Same way in your programming. Now in this algorithms, when we do, you actually code it. So when we code, what happens? When we go wrong, we start tracing it. Tracing from where? Back. Okay, when I did this, what would happen? Especially with my loops. That's why the name backtrack. When we are doing here the backtrack, I start from a point, then I divide it. This could be my solution. This could be my solution. If it is from one side of the solution, we go to the full depth till where I can get a solution. If not, I backtrack to the different levels and see whether I can get that particular solution. Maybe when I'm telling it theoretically, you may not understand what it is. Let us see a problem with a concept of backtracking. It is called a subset problem, where a certain set of elements are given and a desired sum out of it is given. So you have to find out in the combination of that given elements in a set, which makes that particular sum which combination makes that sum. Okay, so let me write that subset problem and let us see how the backtracking works. So now the set given to me here is A. The elements here are 3, 5, 6 and 7. So this has to come up with a sum of 15. So you have to find a combination of this which would give result to me for a sum of 15. Very important thing, always when the set is given, you have to see to that this is arranged in an ascending order. Now in this problem, very important, in this problem there is no issue because it's already in an ascending order. But whereas in some problems, when it is not given, you need to arrange it in an ascending order, then apply this backtracking technique on it. So now let us see how do we find the sum. So our starting point, we would start that the sum is 0, right? And then we would branch into the first element with 3 and without 3. 3 is nothing but the first element of this set. So with 3, what would be my sum here? It would be nothing but 3. It is 0 plus 3, okay, which is nothing but it is 0 plus 3, which makes it 3. So then what would be here? There would be no difference. It is 0, right? So now I would go into the depth of this. Now here again I can go with the next element, that is 5, and another without 5, right? So with 5, this would be what? It would be already there is 3 plus 5, definitely it has to do the 8. So is 8 still feasible solution? Yes, because it is less than 15. Okay, so when I am getting the solution, let me go into the deeper part of this. Then I will go to this with the next item, that is 6 and without 6. So when I do this, what would 8 plus 6 give me? It would give me 14, right? So is 14 less than 15? Yes. So it is still a feasible solution. So I will again branch it with the next item, that is 7 and without 7, right? So now when I go over here with 7, it is not feasible solution because 14 plus 7, which would be 21, which is not less than, it is not less than 15, our desired result. So it is not an feasible. Here without this, it would be 14. Even this is not a solution because it is not 15. I am searching for exact 15. So even this would not lead me to the solution. So I need to go back over here at the same level. Was there any value? Right? Yes, there was a level here which was without 6. So without 6, what was the sum calculated here? So it was without 6, it would be what? The same value whichever was here. So again it is 8. But now after 8, so again I can do with, I had come up till 6. So with 7 and here without 7, right? So with 7, what it would make? It would make the value 15 here. Actually I have got a solution here for which I am looking. So here I added the value, what? It was 3 plus 5, then 7. So what happened? It was 3 plus 5 plus 7. So it is 15. So this is how we got this particular solution, right? But still we have got many to explore. We may have a better solution than this. So we will go to the next one. So now without 7, it would be 8, which is not feasible because the value was not 15 and we cannot go to the more depth. So we were up to here. We will again backtrack to the next level here. So 8 has been. So there was one which was not solved over here. So that is this. So without 5, it would be still 3, right? So then again I will branch from this. It would be with after 5 it is with 6 and without 6. So with 6 this would make 9. Without 6 it would make again 3, right? So with 6 it would be again what? It is 3 plus 6 which made it 9. Okay. So then again I can branch here with the value 7 and without 7. So with 7 here, what would happen? It is 7 plus 9 is not feasible because the value goes more than 15, right? So that is not a solution. Then without 7, it would be 9 and also not a solution because it is much less than the 15. So then again I would backtrack here. At this level we had left somewhere without 6. So now again I can branch over here and say with 7 and without 7. So with 7 it would make 10, without 7 it would make 3. So again this is not feasible solution because it is not leading me to the 15, right? Again I will backtrack to my this here, coming back to this, back to this, back to this. Okay, there was one more level which was not explored. So here it was without 3. So again I go over here. It is with 5 and without 5. So with 5 it would make 5 and without 5 it would be again 0. So this is nothing but 3 plus 5. So with 6 without, without 6. So with 6 it would make me what? 6 plus 5, 11, and here it is 5 only. So again with 7 and without 7. So the value is not feasible because with 7, 11 plus 7 it would reach more, and without 7 I would not be able to reach the required 15 what I want. So again this is not a solution. Then coming back, this is one which was not explored here. So even that without 6, now here with 7 and without 7 also it would not give me solution because 7 plus 5 which is 12, and without that it would be same. So here without 5, if I do here again, even none of them would give me solution. It would be all less than this. You can do and check. So it means our solution whatever is here. So how did you come to this solution? What you had? You had here 3 and you had here 5 and you had here 7. So this was the combination which was done through which you got the subset 5. Desired output 15. So again to summarize, in case of the backtracking, we try to the depth of the solution, when we don't get and it's a dead end, we back to the next level and see whether kind of a problem of subset, you would be given set, okay, which is in some order, but preferably in this mandatory it should, and when you add certain combination of it D, okay. Okay, the set is 1, 2, 5, 8, 6. Okay, so this is the assignment problem for y'all. Okay, or the homework what you say, and this should add up to 9. So the subset is here and this is 9. Closely please check your set, and the whole set should make the sum of 9. If not, the set first you have to arrange it in ascending order. Just go through this.